Good morning, my superhumans. Just before I get into it, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. I hope you're having a great weekend so far. As you can probably tell, I have had to switch back to my crappy internal camera because just before going live with this live stream, I grabbed my main camera to stick it on the tripod over my computer and reached for the power supply to plug it in, and it's missing, which means I have to run it from a battery and it wouldn't last the entire 2-hour live stream. So that's out. And I don't know where it is. The weird thing is that I don't have anywhere else to use it other than sitting right here at my computer. In fact, this is the power lead that goes into it. What I'm missing is the little battery block thing. It's a thing that's like the shape of a battery. You plug it into your phone, into your camera, and then you can plug a power supply into it. So the camera thinks it's running from a battery when in fact it's running from external power. I've got no idea what I did with it. It's got to be here somewhere. It must be within like a meter of me, and I can't find it. I've spent the last 20 minutes looking around and I don't know. So you get what you get. Internal camera it is today. So we're going to try a couple of things today to make it go a little more smoothly than the usual rabbit chasing that I normally do. Last week I did a terrible job of keeping up with the live chat. Now what I did was took questions from Patreon and GitHub sponsors, supporters before the live stream and talked about those, which meant that by the time I got to the live chat, I was an hour and a half behind. So what we've done this time is I've got a couple of people who have very helpfully offered to pull things out of the live chat and feed them to me by a back channel so that hopefully I won't overlook too many things. So before we get into it, there were a couple of questions at the end of the live chat last week that I didn't address, basically just because I was out of time and I didn't catch up. So let's have a look at those ones first. Vicky Fermancia said, may I ask your opinion about CAN bus protocol? Loxon, I'm not sure if you pronounce it Loxon or Lox1. I'll say Lox1. Home automation is using it. Automotive industry is using it for decades because it's robust and simple. It's only using 2 wires. Sorry if it's off topic. No, it is absolutely not off topic. That is perfectly on topic. It ties into some very long ongoing discussions that have been happening on Discord and before that on the forum. This sort of thing has been going on for a long time. It comes down to that whole big question of how should you do link things like light switches together. And there are so many options. I'll try not to go into the big picture too much because it's been discussed before. Let's talk about CAN bus. So, CAN bus is something that I am personally extremely interested in for a home automation, from a home automation standpoint. And as a very brief background, CAN bus, so CAN stands for Controller Area Network, and it was originally developed for linking control systems within cars. So if you have a car with a primary management system and then it's got subsystems to deal with different things like the door locks, etc., those different components need to be able to send messages to each other. So you can think of it as being like a LAN for a car, for all the elements in a car. So it needs to be able to deal with a very noisy electrical system because car electrical systems are horrible places. They have big voltage spikes. Needs to be reliable, obviously, because if you're sending messages between the main part of like your your engine management system and your anti-lock braking controller or whatever, you need to make absolutely sure those messages are getting through. So it needs electrical reliability, it needs prioritization of messages, so high priority messages get through in place of low priority messages. It is, and it's been used a lot in industrial work for that, for all those same reasons. So, I mean, I've demoed this thing before on the stream. There's that big yellow robot water cannon thing. The controller on that has CAN bus in it. So I designed the controller that is running on that. And I've also done quite a bit of CAN bus work, both in cars and also for assistive technology projects. Modern wheelchairs have CAN bus on them. They are very sophisticated. So, and I even did a project with my friend Chris where we added a CAN bus interface to a FlySky radio transmitter. Where is it? That's. It's not this exact one, but it's like this. We have a, I've probably got it just down around here somewhere. We have a FlySky transmitter with a board that we designed that fits inside. It connects onto the programming header of the internal controller, and we've added a socket, so we've got a CAN bus interface, so that what we can do is use CAN messages to fly drones and aircraft by sending the commands to the transmitter. So I've done quite a bit with CAN bus, and I really like the concept of it. Oh, and the other thing is, a related technology is called LIN-bus. And a few years ago I did a video showing the control system for my window motors. So in the conservatory we've got 4 windows with motors that allow the windows to open and close automatically. Those have a LIN-bus interface, and I designed a board with LIN-bus to link those to my home automation system. And LIN-bus essentially is a subset of CAN bus. CAN bus is very extensible. LIN-bus is like a, you could say it's a dumbed down version of CAN bus, and it's also used in cars. The idea is that you use it for like the last meter connection between something like the controller that handles the electric windows and the window motor. So the motor will implement a LIN-bus interface, and the controller will be able to send commands to the motor to say start, stop, direction, whatever. So I actually already have LIN-bus in my home automation system. Okay, so why don't we all use CAN bus in our home automation systems? The major reason that I can see is the complexity of the software stack. It is remarkably hard to implement the software that's required to go into the microcontrollers in the devices to support the protocols that are typically used on top of CAN bus. So CAN defines a few layers of the stack. If you think about communication, starting with the bare wire that links things together, and then there's the modulation scheme that goes on top of it, and then on top of that there are different layers all the way up to the actual messages that you want to send, like the data you care about. CAN bus defines most of those layers, and then right up to the top level you can run your own top level protocols on it. And what you can do is treat a CAN bus as if it's a simple serial connection. Well, not quite simple. You can't really treat it as a simple serial connection, but what you can do is send just raw packets of data through it, or frames. So what you can do is say, I have these bytes of data and I want to send them. You can do that. That's relatively easy, and that's what we're doing in the radio control transmitter project. But to do it properly, you need to implement a system like CANopen or one of the automotive-oriented protocols which do things like allow you to plug multiple devices in and have them auto-discover services, and they implement a thing called a dictionary which defines these particular data endpoints are available and this is how you access them. And all of that is a whole lot of scaffolding that you have to take care of, and the documentation for that is largely locked up in guides that you have to pay for, like very expensive specification documents, and it's quite hard to try to make something that is compatible with those and that is robust. So I'm not going to go into this in a whole lot more detail right now. I think I've already spent enough time talking about CAN bus. The summary is I really like it in some ways, but the barrier to using it is just a bit too high for hobbyist type home automation projects. Now, if someone did a whole lot of groundwork and put in place building blocks that could be used, like doing the electrical side of the CAN bus interface is easy. All you need is something like an MCP 2551 and a 2515 as the CAN controller and the CAN driver, and it's not that expensive. It's a few dollars worth of parts. They're easy to get. They're easy to route on a circuit board. It's not hard to design the electrical side of it. The software layer that sits on top of it is the tricky bit. So if there were readily available libraries that you could build into your project and then use those to handle the discovery portion, I would be much more inclined to use CAN bus in my own home automation system. But it's one of those things where the barrier of getting to something useful is high enough. It's not like hours of work, it's weeks of work. And that is enough to stop people using it. Now, companies that do this commercially, make lots of money out of it, they can afford to have very smart developers working on things for weeks. But for typical hobby projects, that sort of thing isn't so practical. All right. So, a couple more hangovers from last week's question. So, Christopher Jones said it would be a great idea to compare Node-RED, Home Assistant, and OpenHAB. There are too many comparison articles online by authors who haven't really used each other to any real extent. Now, there is a video from a couple of years ago. I'm going to switch over. Oh, here we go. So this is a video of Dave Cole, who is an active member of the Discord. I'm going to chuck this URL into the chat. This is a video that was recorded at a meetup in New Zealand, and it is basically what Dave has done is run both Home Assistant and OpenHAB in his house simultaneously. And this talk is a direct comparison. He shows screenshots of the user interfaces for the mobile apps and his perspective on what it's been like setting up both systems. So that's worth checking out. For me personally, I have very little experience with Home Assistant, and my experience with OpenHAB has been mostly with the 1.x series codebase, and the 2 series is very, very different. So I'm not a great person to be able to provide a perspective on that. I've used OpenHAB 2 a bit at Chris's place, but I haven't got it running in my own house, and I don't have Home Assistant running in my house. So that would be, yeah, so go and check out David's talk after this. Nuno asked what I think about the Esperna firmware. I've never run it. I've looked at it. So for those of you who don't know, Esperna is firmware that goes onto devices like a Sonoff. It's essentially a direct competitor to Tasmoda, and there are a number of different firmware alternatives that you can put onto ESP8266 devices. Esperna is one that you can flash onto the device in place of whatever the original firmware was, like eWeLink or whatever, and it gives it a whole lot of extra functionality and the ability to directly control the behavior of the device. So personally, I've used Tasmoda and I love it, but many people use Esperna and they love that as well. I can't speak from personal experience though. So this is something that would be interesting to hear from people in the chat who have used Esperna, and particularly people who have used Esperna and Tasmoda and maybe other alternatives, and can talk about the differences between them. So that's the sort of thing. We have a firmware, in fact I'm going to put another thing right here in the chat. I should have some of these URLs ready to just cut and paste, but I don't. So there is a section in the Discord specifically for discussing firmware, and if you want to talk about that, that would be a good place to do it. But I don't personally know about Esperna, so I can't talk to that. And finally, Ecognito3 said, what's the URL for the company with the certified Sonoffs? Sounds like Oikotech. It is exactly Oikotech. And I will find that now. Oikotech. I'll find the page with the products on it. So what Oikotech have done is taken a couple of specific Sonoff models. So this is Oikotech. So if you're in Australia and you want to buy Sonoff models that have been certified, then you can buy them from Oikotech. There are two models that they've paid for the lab testing and going through all of the certification process. So that's quite a it's a very expensive process. IT'd have not paid for it. They haven't done any certification for Australia. Oikotech took it on themselves to buy devices from IT'd, take them to the lab, get them tested, get the certification done, and get them approved. Now, a warning though, that does not mean that you can just go out and buy Sonoffs and they are approved. You need to buy them from Oikotech because the certification only covers so the way it works is if you import a product from overseas and you have that product certified, that certification only applies to your distribution of the product. So if you go directly to IT and buy that same product, it's physically the identical thing, but it's not certified because you are not buying it from the entity that has the certification issued to them. Now, if IT had obtained the certification, we could all buy it directly and it wouldn't be a problem. But because Oikotech have gone to the trouble of doing that, and big props to them for doing it, you have to buy Sonoffs from Oikotech for them to be certified. And that page that I dropped in there, the Oikotech link, that is a product page which has a whole lot of other products on it, not just Sonoffs, but if you scroll down that page, so they do CCTV stuff and things as well. I don't think there are specific pages, but they've got the Sonoff Dual and the Sonoff POW R2 both certified. So the Sonoff Dual they sell for $29 Australian, the Sonoff POW R2 for $36 Australian. And as you can see, that is quite a lot more than you would pay if you simply bought the Sonoffs directly from IT. But if you buy from IT, there is no certification. So what you are doing essentially is helping Oikotech to offset all of the expenses that they incurred in getting that certification done, and that's a really important thing. I think it's great that they've done that. So if you are wanting certified Sonoffs, buy them from Oikotech, please support them. That would be cool. Now, on to a couple more questions. So when Sorry, my brain is jumping around a few different things here and wondering what to talk about next. Okay, after a lot of delay, I finally got the integration working between Patreon and Discord yesterday. So if you are a supporter on Patreon, you should automatically have been given a special role in Discord and be given access to a financial supporter section which has got hidden channels on it. So if you're in that category and it's not working for you, please ask for help, like in the general, like in Discord. This is not really the best place to do it, but we'll try to get you linked into that. So the idea is that through that I'll be able to do things like take questions that arise through that section and then address them directly on the live stream. Now, a couple of things that came up. James O'Gorman asked a question which is, this is something that's really interesting to put out to the general audience as well. I'd like to hear opinions on this. His question was essentially the best and worst parts of my home automation system or anyone else's home automation system in relation to acceptance by other members of the family. So I'm a nerd, I love hacking on things. I treat my house as if it's a big toy and I modify it and do fun things with it. But my family don't necessarily share that same passion. So doing things like changing light switches and modifying stuff around the house can get people upset, and it can there can be resentment. I've been extremely lucky that my family is very patient, and the house has it's crashed a few times and things have stopped working, and they just acknowledge that, oh well, that's just because I'm me and I do these silly things, and I get away with it probably far more than I should. And but the counter to that is the positive side of it, and that is things that your home automation system has that are actually cool and useful and your family think are good, and it makes the whole project worthwhile. So for me, I'll give my answer, and then I'd like to know what other people think about this. The downside, the thing that causes the most friction and the most annoyance, I think, is the mobile interface. And at the moment I'm using the Node-RED dashboard plugin, which is very laggy, and that combined with probably when the light switches stop working are the two things that are the most annoying. And my family have kind of got used to working around that when it happens. So yeah, they're not, the thing is that I don't get a huge amount of pushback, so I'm kind of lucky in that respect. But I think probably the worst thing is frustration with the user interface. For example, in the evening, sitting on the couch watching TV with my wife, and she'll want to turn off the lights, so it's cool, we're sitting, you've got a blanket over your legs and you're all cozy, and pull out the phone to turn off lights around the house, and then you open Node-RED and you sit there and it doesn't open, and then you wait, and then like 10 seconds later it opens, and then you press the little thing to open a pane, and oh, come on, wait, click the button. Now, I know it's a bizarre first world problem to be complaining about the latency of a user interface controlling your house from your phone sitting on the couch, when the ability to do that at all is pretty cool. But still, that is it's a friction point or a pain point. Alright, so good aspects of it. Probably conversely, that is probably also the good aspect of it. It is being able to sit there and turn off the fan in the laundry while sitting on the couch because the dryer has finished, or you turned it on earlier, and then you can just look at the interface and see what devices are turned on and off around the house. And the ambient display, I know I keep bringing this up, it's one of those weird projects that I didn't think would be so useful, and it's turned out to be very useful. That is actually really cool. That has been one of those positive things where being able to have that information presented to you, like what bins need to go out, UV warnings, those sorts of things, in the kitchen, so in a living space. It's not a computer interface. I think that is really key, and I want to do a lot more exploration of that. Many years ago, one of the early projects that really got me started off on all of this was I saw a project with an umbrella with a display in the handle, and the idea was that you'd have your umbrella sitting inside the front door, and the handle had an LED or something on the end of it, and when it was going to rain, the LED would flash or glow or whatever. So as you're leaving, you would know whether you need to take the umbrella with you or not. And that, once again, it's one of those things that sounds silly, but it's the concept of having user interfaces and interactions built into the environment around you. That's what's really interesting. It's ambient information. And many years ago, I actually registered the domain name ambientiq.com because I was interested in pursuing the idea of building intelligence into the ambient environment. And I've never done anything with that domain, but it's kind of come out in some of the projects I've done where I like to work on things with non-standard user interfaces. One of the projects that I'm going to do a video about is a smart mirror. I've got all of the stuff for that just through that doorway. So I'm going to make up you've probably seen these projects before, a mirror with a computer display behind it so that it normally looks like a mirror, but you can also display information within the mirror. And you can do things like have touch interfaces around the edge, like of the frame. So you can make it look like a normal ornate mirror, and aesthetically there is no visible interface, but it's a way of presenting information in context. It's not going to your computer and sitting at your computer to use it. It's doing something in your normal environment and having information or interaction specifically in the context of that environment and that activity, whatever it is that you're undertaking at the time. So I like those sorts of things. And those sorts of ambient displays, I think, are the sort of thing that are positives in terms of other people accepting. Okay, so now there are a couple of other questions, but I'm not going to answer them all now. There are some that I might come back to. One point that James said though is, I'm assuming that Sion didn't get the fire extinguisher yet. That's on him now. So, yeah, Sion has had some distractions getting his pick and place machine sorted, and that's a whole world of pain that he's done videos about. So go and check out Unexpected Maker if you want to see all of the frustration he's had. But he's had other things to worry about rather than fire extinguishers recently. He's got to produce thousands and thousands of tiny picos with a pick and place machine that is throwing parts around the room like confetti. So yeah, I'm sure he'll get a fire extinguisher when he gets a chance. So, but James's point is, it may be a good time to remind people to check their fire extinguishers and smoke detectors just because. and I often forget to check mine. Yeah, so check that your fire extinguishers have had their pressure tests and your smoke detectors have batteries in them, etc. All good safety tips. Okay, so there are a couple more questions that I will not get to right now. I might come back to it in a second. I've got to check because I've been ignoring my back channel, and let's see what other things have been highlighted to me. Oh, Genomini, how do I pronounce that? Genomini said you never showed your whole setup Node-RED environment for years, and now you just did that in the last live stream. Why did that take so long? I probably because I didn't think there was a lot there that was worth showing. I'm certainly no Node-RED expert, and part of it is this whole feeling of I don't want to show things and embarrass myself because I'm really not an expert on most of the things that I do. I just fudge my way through and try to make it work. But I need to be more more forthcoming with things that are in progress. And Andrew Gordon asked if I've seen the Get Wired project on Crowd Supply using RS485 and my sensors for end nodes. No, I will have a look at that. Thanks, Andrew. So in my discussion earlier about CAN bus, I didn't mention RS485, which is a serial communication system conceptually similar to CAN bus, but very different in its implementation. It's used for multi-drop serial, where instead of regular two devices connected by a serial link, which is the way most of us think about serial, it's a bus. So you can have multiple devices all connected together. So you can have a piece of wire that is looping around between all the devices, and you can pass messages between them, and you can have IDs of different devices, so you can send a message from one device to another, and other devices will ignore it, etc. Very similar to CAN bus in that respect, but a totally different implementation and much low. How do I put this? I'll say it's lower level because it doesn't have such a big hierarchy of the communication stack defined. It's more of just here is a link and send whatever you want over it. So it's kind of up to you to define your own protocols and all of that sort of thing. So RS485 is, I would have to give a fair bit of thought to it, but RS485 is actually something that I've considered using as the link between my light switches and other devices, and it would allow a system that is much more like something like Clips or C-Bus, where you can take a piece of twisted pair cable and loop it around between all of your endpoints, and you could do things like push firmware updates over the link. You could send configuration over the link. You could do some auto discovery. It's robust against electrical noise. The links run for a long distance, so you can have many meters of wire between devices, just like CAN bus. So in some respects, RS485 and CAN bus are competitors. Conceptually similar, extremely different in implementation. Anyway, Andrew, thanks for bringing that up. I'm going to check out the Get Wired project. And another question from Genomini. You ever thought about using HomeKit or HomeBridge instead of a custom dashboard? Yes, I have. I haven't gone into it in any detail, but the thought has crossed my mind, and I really need to look at that. Now, the thing is that my current setup with Node-RED and the Node-RED dashboard plugin was only ever intended to be a short experiment. And however long later, like a year and a half, 2 years later, I'm still running that same experiment and I haven't moved on from it. I was running OpenHAB. I was in the process of upgrading to OpenHAB 2 when it came out. So a couple of years ago, whenever this was, and my configuration broke, and I was wanting to experiment with, at the same time, was replacing my hacky custom scripts. So it was that time that I've explained this on previous live streams. It was at that time that I installed Node-RED with the idea of, let's just see if I can run the whole house on Node-RED. And a bit of messing around over one weekend, and I had the whole house running on Node-RED. And I thought, oh, this is cool. I'll just see how this works. And all this time later, I've still got that temporary Node-RED lash up running the house. But that's not my ultimate goal. I'm probably going to go for something that is rather more purpose-built. Like I expect that I will switch back to either OpenHAB or to Home Assistant or something, and then I will end up redoing the user interface. So, okay. Tom Cassidy said, saw the RGB momentary switch video. Any plans to replace your switch buttons? Can you still use a single Ethernet cable to connect them? And yes, that is where I'm going with it. I'm going to end up doing a whole mini series about this, so I'm not going to go into it in great detail now, but I'll give you the summary. So what I'm doing is I'm kind of stalled at the moment on the air quality sensor mini series. I've got 2 more episodes that I want to get out with that. I need to do the episode about storing and reporting data and what the data actually means. That's going to be part 4. And then part 5 is going to be the Air Quality Sensor Pro, which is the version with the PMS 7003 sensor. It's got an ESP32 on it, USB-C. It's on a custom PCB with a 3D printed enclosure, big display on it, like a 240 by 240 LCD, full color LCD. Looks fantastic. That's going to be part 5. And I want to get those out of the way. And then I've got a couple of other single episode videos. But I've also got a mini series planned for light switches. I think this is a topic that really deserves a lot of focus. And it's probably beyond using something like Sonoffs or other Apple controllers to control lights, solving the light switch problem is probably the biggest barrier for most people that are doing DIY home automation. That whole thing of how do I have physical controls on the walls that allow me to interface with my home automation system and also allow it to be controlled from a phone or from other interfaces. And obviously I've done a fair bit of stuff with that over the years. And the new light switch controller, which is that rack mount device that I showed on the last live stream, and I've shown it on other live streams, is going to be the core of the new generation, I suppose, of my light switch system. But it's designed so that it can support multiple types of light switches as the end point, depending on what you want to do. So what I've done is maintained backward compatibility with my existing simple light switches, which is just a button on the end of a wire, and power so that the button can be illuminated. Those work over twisted pair at the moment, so I'm just using I'm using Cat5e, and there's an RJ45 socket on the back of the light switch, so you just plug the cable in and it works. It's not Ethernet, it's just using the twisted pair cable. But beyond that, I also want to be able to have RGB illumination, and I want to be able to do things like show the status of the load on the switch. Now there's a classic situation that we have in our house where we have light switches in the laundry, and so in the laundry we've got a clothes dryer and there's an exhaust fan. If the clothes dryer is running, it's so loud that you can't tell if the exhaust fan is on, because the exhaust fan is reasonably quiet. And so you can stand there pressing the button to turn the exhaust fan on and not know if you've turned it on or not. And the switch really should show the status of the load. It needs to change color or get brighter or dimmer or whatever to indicate whether the device is turned on or off. Now, of course, in that specific case, there should also be things like humidity sensor to turn the exhaust fan on automatically if the clothes dryer is running and it's causing humidity, or it could be done by measuring the load. That clothes dryer is actually connected to a on-off power, so I can tell when it's running or not. But that's a different issue. My point is that the light switches really should show the status of the load on the switch panel, so you can just look at it and know whether something is turned on or off, which could be very useful for things like a light switch inside that controls lights outside the house. You know, if you've got your outside lights on or not. So what I've done with the RGB light switches is integrate an ESP8266 into them and kept the interface in terms of how it communicates over the wire the same. So when you press a button on it, the ESP8266 knows that you've pressed the button, and it can update the state of the light, and it also shorts across the wires, so the switch controller knows you press the button, and it can do something like change the output state. Now the issue with that, of course, is synchronization of the state display if the load gets changed somewhere else. For that, at the moment, what I'm doing is using, on my prototype, so I'm just using the Wi-Fi as the back channel for synchronizing states. So the light switches can publish to MQTT, they can subscribe to a topic, so they can be notified when, when the state of a load is changed, and then update their own display. Now, I know many people are going to say, hey, you're using Wi-Fi for your light switches. And this is something I kind of debated a bit, because it's really splitting that line between critical functionality that you must have working and nice to have functionality. So this is one of those situations where you have a trade-off. It's I mean, engineering is all about trade-offs and compromises and deciding which is the most important thing. So the way I've got my prototype working at the moment, if Wi-Fi is broken, the buttons will still work because the wired connection is used for sending the button press events, but the status display won't update. If your Wi-Fi is working, then the status display on the switches updates. But that's not critical to the functionality of the switches. It's like an extra flourish or a nice to have extra functionality. So ideally, I would have all of that communication go through the wire, and that's where something like RS485 or CAN bus would come in. So the next stage beyond that is being able to use some kind of a serial communications link through the twisted pair, so that the light switch can send and receive messages through the cable. And that is the next step beyond what I currently have on my prototypes, which is relying on Wi-Fi. But anyway, that is all going to be addressed in the light switch mini-series, hopefully. Alright, oh, and on my back channel, I got a note from my friend Andy to say, to mention the story about sourcing the custom RGB switches. Yes. Let's see if I can find them. I think, yes, they are just here. So this is a box of some prototypes, and alright, I'm probably going to mess this story up, but here goes. So a couple of years ago, I was in Shenzhen, China, with Andy, and also with another friend, John Boshua from LifeX, and I think it was a weekend when we arrived. I can't remember. It was probably like a Saturday afternoon, because we walked into the electronics market in Shenzhen and it was deserted. Half the stands were empty, and there was nobody around. There were only a couple of stands that had anybody in it. And I'd gone there. One of the reasons that I'd wanted to make that trip was that I was wanting to source switches that were similar to the switches that I've been using in my light switches, but that are RGB instead of just single color. So we went to, as we were walking through the market, we found a stand for a company that sells all sorts of switches, like industrial switches and things, big displays of lots of different types. And they were basically they're an outlet for OnPower, which is one of the biggest switch manufacturers in China. And they've got a huge catalog. It's like a small phone book, all glossy with photos of all of the different models of switches and things they do. But the thing is that companies like this can customize. And the person behind the counter didn't speak any English, and I don't speak Chinese. John gets by extremely well with using live translation on his phone, and so what we did with a bit of pointing and some diagrams and showing things in the catalog was explain that what I wanted was something similar to one of their switches, but RGB, not just one color. And so the person at the behind the counter got on the phone to her contact at the factory, and spoke to an engineer, and John got a friend of his from LifeX who speaks Chinese on the phone and put the phone on speaker so that we could use them as a translator. So the two of us were standing there working through a third party, acting as a translator and trying to explain exactly what I wanted. And the person we were talking to was likewise taking that and relaying it back to the engineer to see if they could do what I needed. So the end result of all of this was that we drew diagrams, and I explained what pinout I wanted, and they said yes, they could do custom switches with RGB illumination, and the minimum order quantity I think was 200. Yeah, they would do it for a run of 200, and they could have it in I think it was about 10 days was what they estimated. And I wasn't going to be in China for 10 days. I was only going to be there for about 7 or 8 days. So they weren't quite going to be ready in time for while I was there. But I ran over to an ATM, got out some cash, paid my cash over the counter, and that was that. So after I left China, John was still there because he was living over there doing stuff for LifeX production, and so he gave himself, I think, as the delivery address, and they sent these to him. So this one, it's never even been opened. So these are custom-made RGB illuminated buttons. This is one that I've taken out of the packet, that were created by OnPower, and when I received them, they've even got printing on the back showing the pinout. And all of this was done because I specifically asked for it, drew the diagram of what I wanted, and within the space of 10 days they produced custom switches for me. And the price on them, I can't remember what it was, but it was ridiculously low. It was like cheaper than you would pay for an illuminated switch, like just in a regular, from a regular Western supplier. And they were custom made RGB in 10 days. So that was pretty incredible. And it was even more amazing that we managed to negotiate the whole thing by drawing pictures on a piece of paper and working through a translator on the phone. And it was, it took maybe half an hour. So walking up to the stand and discussing it, paying, placing the order, paying for it, and walking away half an hour later, and then custom switches came my way. Yeah, John ended up bringing them back with him. So he was coming back to Australia a little bit later, so he chucked them in his luggage and brought them back. Now, even even with the back channel that are feeding things to me, I am falling behind. Mike O'Connor and Tom Cassidy both said that ESP Home is interesting. The firmware setup is controlled by a config file, and Sausage is using ESP Home to connect Olimex ESP32 PoE. Cool. So I don't actually have one of those Olimex ESP32 boards. I've got a few ESP32 PoE boards, but they are they're not the Olimex ones. They are the where are they? Somewhere up here. I don't know why, but my brain has wigged out on me, and I can't even remember what it's called, despite the fact that I've used them many times. You know those things? It's like forgetting the name of the member of your family or something. Now I see that there was a question from Jordan Reese who said, I have those buttons, like the RGB buttons, but lost the nut. What size are those? Let's see, I have one here, 15.8 millimeters, external to the thread. Yeah, it's a 16 millimeter hole, but I don't know the specs on the thread type. That's a good question. I can't actually answer that, unfortunately. I'm sorry. The only information I've got is what I could measure off this. I might have to, I think that would take a bit of digging to find the specifications for the thread. So, I'm sorry if I'm mispronouncing this name. Genomini, actually I'll say Genomine, because I think that makes more sense. What problems do you have with the Node-RED dashboard? Pretty stable for me. Yeah, it's stable, mostly. On my wife's phone, it often just doesn't load. I'm using an Android phone, she's using an iPhone. It always loads on my phone, and it often goes through periods where it doesn't load on hers. Like it'll just stop working for a couple of weeks, and then it'll come back again. The main problem is just the latency. And it doesn't look as pretty as things like the OpenHab app. Okay, yeah, so latency. It looks like Scott Miller has mentioned that as well. And Scott Hansen asked, why did I stop using OpenHab? It has a good app and web interface. Okay, the main reason I wasn't actually intending to stop, that's the thing. I had OpenHab v1.x. I've been using OpenHab for many, many years. I started with it in the very early days, and I had my whole house running on OpenHab. But the change from the version 1 to the version 2 series was radical, and I did actually install version 2, and I began to migrate my configuration over, and it was broken enough that there was no point trying to just migrate. I thought, in order to do this, I just have to start the configuration from scratch. And that was why I started thinking, well, if I'm going to do it from scratch, I might as well experiment with other things. Let's try Node-RED to see if I can make that do what I want. And my plan had always been that after I tried that, a couple of weeks later, I would set up OpenHab. And I just wanted to learn whether Node-RED could do it. I've learned that it can. So there is no real specific reason that I've stopped using OpenHAB other than I needed to update, and the update process broke my house, and I haven't got back to reinstalling it. And I do really want to install Home Assistant as well. I want to have both systems running just so I can have some clue about how they compare to each other. What would be, I know it would be a lot of work, but what would be really interesting would be to have a complete Home Assistant setup and a complete OpenHAB setup running on, maybe running on 2 Raspberry Pis or something, and the ability to run the house on either one or the other. Now, of course, keeping the configuration synchronized would be a real pain. I'd have to make changes to one and then make the same changes to the other. But I think it would be a really interesting comparison. By that I mean not just have part of the house controlled by one and part controlled by the other. I'd like to have it possible to run the entire house off OpenHAB or the entire house off Home Assistant and just be running one or the other, and be able to do a proper A/B comparison. Yeah, so now David White said the voice interface for assistants is something I've really started to rely on. Are there any open source ones? I like Google but prefer She Who Shall Not Be Named because its name can be computer. Damn, the fact that I said that might have just woken up your voice assistant. Sorry, David. Yes, this is another big topic that I really want to get into. And for me personally, the answer to this is Mycroft. Mycroft AI is a fully open source voice assistant. I've mentioned this a couple of times on live streams previously, and I'm intending to do a lot of coverage about this in the future. I've got both genuine Mycroft hardware here, and I also have DIY Mycroft installation. The thing is that the cool thing about Mycroft is that their objective is to build a fully open system, and to both in terms of how the device works, the firmware that runs on it, and the back end, so that you're not relying on some third-party cloud service that you've got no control over. So it's about data sovereignty, having control of your own, all of your own recordings, and about total control and open source of how it behaves. And part of that is that they very specifically target readily available platforms like Raspberry Pi. So you can build a complete Mycroft voice assistant using a Raspberry Pi and a Bluetooth microphone. Well, it doesn't have to be Bluetooth, but typically what like the normal reference installations or reference systems, you use something like a Bluetooth microphone speaker, which can be paired up with the Raspberry Pi, and that allows you to talk to it and for it to give its responses back to you. And that is all the hardware that you need. I mean, there are other things you can do. You can make it more fancy than that. You can use multi-microphone arrays, which I have, so that it can do discrimination of voice in a specific part of the room and block out background noise and echo cancellation and all of those sorts of things that are done in the proprietary voice assistants. You can do all of those things using Mycroft as well. But you don't have to. You can get started by just downloading the Mycroft software, running it on a Raspberry Pi with a microphone and a speaker. And it doesn't have to be Bluetooth. You can just have a speaker and microphone plugged into your Pi. It could be on USB or whatever. And you can build yourself an open source voice assistant. Now, my friend Kathy worked at Mycroft for a while, and I've spoken to her recently about possibly coming on the live stream to talk about open source voice assistants, and hopefully we'll get to do that fairly soon. That would be super cool because Kathy is the expert on this stuff, and I'd love to hear what she has to say about it. I think it could be really useful. All right. Okay, so a couple more comments. Scott Red, oh sorry, I'm reading multiple words on the same line. Scott Miller said, my systems all run on Node Red. Node Red is just the rules and such. Dashboards is handy as a UI but not required. Main point is everything talks MQTT and Node Red is just the logic server. Yes, exactly. So MQTT is the key here. That really is the glue that allows you to take otherwise unrelated systems and link them all together. And if it wasn't for MQTT, I had to think where we'd be right now. Basically, it would be API hell. We would have a whole lot of different software systems running, each with their own API defined, and then we'd be doing things like writing glue code that talks to the API of one thing and then links to the API of another, and you'd have authentication issues and all sorts of things. MQTT is the common language that just makes everything work. So my general rule is that I pretty much won't run anything in my house unless I can make it talk to MQTT. Now, soon, speaking of guests, fairly soon we'll probably also have my friend Andy on the live stream, and he is the smartest, most well-informed MQTT guru that I know. He's the one that got me involved in it, and so it'll be really cool to have him on too. We'll do that soon. All right. Oh, here's an interesting question. I'm not quite sure if I understand it, but let's see. Christopher Jones said, I'd like to replace my house light switches with momentary push buttons, but keep the twin core wiring and then run the switches and lights to new ESP modules. What's the best way to do this on a large scale? Whole house. Okay. Replace the light switches with momentary push buttons, but keep the twin core wiring and then run the switches and lights to new ESP modules. Now, this is, if I understand the question correctly, I may not. One of the one thing that you have to be really careful of is using the wrong type of cable, using cable for a purpose that it wasn't intended for. And this is something that is not necessarily obvious. How do I explain this? If you have mains cable in your house, like you've got fixed 1 millimeter square cross section, twin core mains cable coming down your wall to a light switch, and you want to change that light switch over so that it uses some kind of a logical control or a push button or whatever, and use that to link back up to some other device like a Sonoff in the ceiling. Okay, the classic example of this is you have an existing light switch and a light in the ceiling, and what you want to do is oh, I just saw Mr. DIY just dropped $5 in there. Thanks, Mr. DIY. And you want to change it so that your light switch, instead of directly switching the mains, is a logical input to something like a Sonoff Mini mounted inside the ceiling that is near the oh, and Christopher Jones just said extra low voltage. Okay, so terminology is important here. Most people who have not worked as electricians think, when they hear the term low voltage, they think like 12 volts or 5 volts. That is not actually what that term means. Low voltage in the electrical world is mains voltage. It's like 240 volts is what an electrician calls low voltage. And terms like high voltage and extra high voltage and those sorts of things, they refer to things up in the thousands, tens of thousands range. So if you don't get the terminology right, you can end up talking at cross purposes and misunderstand each other. And as Christopher Jones pointed out in the chat, extra low voltage, or ELV, is the terminology when you're talking about, I can't remember what the limit is. I think it might be 50 volts or somewhere around that. So voltages 50 volts and below are ELV. Please someone correct me if I'm wrong. It may not be 50. It may be like 32 or 48 or something. So Scott just said, having regularly worked with 25,000 volt systems, anything in your house is LV. Yeah. So in terms of this example of what I'm talking about, the mains wiring in your house is considered low voltage, even if it's 240 volts. So the wiring that comes down from your light fitting to the light switch with mains on it is low voltage, and then you are directly switching that mains power. So what I'm talking about in this scenario is using the existing light switch or replacing the switch and putting a button in place and switching extra low voltage, like 5 volts or 12 volts, as a logic signal that is going to a device in the ceiling, like a Sonoff Mini is the classic example. It's got two connections on it, S1 and S2, that you can use to connect an external switch, and it can either be a rocker switch or a momentary button, and you can change the configuration in software so that it will work with both, with either. So what you can do is have your regular light switch on the wall, and it looks exactly the same as normal. It's unchanged. When someone flicks the switch, what it's actually switching is 3.3 volts. So it's switching extra low voltage, ELV, and that's a signal that is going to the Sonoff Mini in the ceiling, which is then switching the low voltage, which is the mains. And, alright, getting back to my original point. What this is doing is misusing the low voltage cable in the wall for extra low voltage. Now, of course, it's totally capable of doing that. And if you have a chunk of 1mm square mains rated cable in the wall and you want to use it as a connection between a push button and some device and you're switching 3.3 volts over it, the cable's going to handle it. That's not a problem. The potential problem comes down the track, could be days down the track or years down the track. An electrician comes to your house and you're not there, someone else owns the house, they open up the plate on the wall, they see mains cable coming into a mains rated switch, and they don't see mains voltage on it. And that is potentially a big problem. It could be potentially dangerous because you could end up with the electrician thinking there is a problem with the supply and applying 240 volts to it, and then bang goes your device in the ceiling because it's expecting 3.3 volts. So there are devices like the Shelly that do this, but they are specifically designed to do it. And I don't know enough about the way the Shelly works to be able to speak authoritatively about it, so I'm not going to say anything that might mislead people. But from my understanding is that the way the Shelly external inputs work is that they are designed to work at mains voltages. I could be wrong about that. Anyway, I'm going to stop talking about that because I don't want to screw everybody up. I need to go and do my homework on it first. The summary is that I think that in the Shelly design they've taken this problem into account, and it's which it hasn't been taken into account with the Sonoffs, which just switch 3.3 volts on the S1 and S2 inputs. Dodgy Brothers just asked, can you put the on-off where the switch goes so it's obvious? Yes, you can. And what you could do, and that's actually one of the reasons that the Shelly, the standard Shelly, they make a few different models, but the standard Shelly is very small and it's got rounded corners. The reason it's that shape is so that you can take a standard US light fitting off the wall, and the US light fittings have a sort of rounded can in the back of them, and you can fit the Shelly into it and then put the light switch back over the front. So what you can do is use the light switch as an input to the Shelly, which then switches the wires that would previously have been switched by the switch. Now, for a standard Shelly, you need neutral as well, but that's a whole other discussion. And that's one of the reasons that for something like a Sonoff Mini or a Shelly, typically they're put up inside the ceiling because you have neutral available there, unless the wiring is recent, in which case for new build houses they will have neutral available at those switches as well. I don't know if I've even addressed the original question. Hopefully I have to some extent in a roundabout way. Alright, so going back to the comments I made earlier about Mycroft, Brendan White asked if I've heard of Almond. It's a Stanford University project that has promise. The open privacy-preserving virtual assistant Almond translates your commands into a personalized program. No, I haven't seen Almond. This does seem to be an area that is pretty hot for research at the moment. And I think a lot of it comes down to some of the advances in machine learning that have been going on over the last few years. And there has been, and once again, my friend Andy is the expert in this, but there has been so much development in machine learning that can be applied to a wide variety of different things. We're seeing it quite a lot in terms of applications to video and image processing, but it can also be used for speech processing. And so I haven't seen that specific project, but that is worth checking out. So there is a link, almond.stanford.edu, that could be worth looking at. So thanks, Brendan, for bringing that up. Okay. So I think I am largely caught up with the comments that have been brought up. Okay. There was another question that came from a patron email through yesterday, and just wondering whether to get into this because it's a totally different topic. It's kind of interesting though. All right, this is something that we might have to come back to later as well, but I'll raise it now as a starting point because I want to get feedback from people. I want to get other input. So the question from John McRae is, I'll use a recent example where I used an EUP 3476 regulator for a 3.3 volt supply to my refrigerator control project. I'd previously used it for a multi-channel composite RGB LED and WS2812B board for the D1 Mini, since I could get the desired 3 amps out of it at 5 volts. Well, 2.5 amps really. However, dropping the output to 3.3 volts for the ESP32 project leaves it using 6 watts driving the ESP32, which seems very inefficient. So my question is, do you have a list of go-to efficient switch mode voltage regulator designs for differing voltage current requirements, say in the sub 3 amp range? Okay, that was a fairly long question, but it's a really interesting one, and I think it's an important one. And I could talk about this topic for a very, very long time. Alright, I'll try not to backtrack too much, but to give a little bit of background, there are, in terms of hobby electronics or small-scale electronics projects, there are 2 standard ways to do voltage regulation. This is a huge generalization, but it's just a useful concept. There are linear regulators and there are switching regulators. And The major difference is that a linear regulator reduces voltage by emitting excess power as heat. So, whereas a switch mode regulator reduces voltage by, essentially turning the power on and off very quickly and feeding that square wave into an inductor and using that as a buffer to produce a smooth output at a lower voltage. That was probably a terrible explanation. But the major thing to keep in mind is that they have different characteristics. A linear regulator is inefficient because whatever the excess voltage is, it has to emit as heat. A switch mode regulator is more efficient because it doesn't emit the extra power as heat. It just turns the supply off and then turn it back on again, turn it off again, turn it on again, and it does that at a rate that allows it to take the amount of power that it needs to power the load. Now, for that to work, it needs feedback, so it needs to know how much power is being used by the load, and it needs to adjust its own duty cycle in order to get the right amount of power going through, and there are a whole lot of complications involved in that. I'll get back to that in just a second. So, thinking about it from the point of, thinking about the linear voltage regulator again, imagine you have a 10 volt input voltage and you are wanting to run a 5 volt circuit that is pulling, say, 100 milliamps. And you want to run that on the output of the voltage regulator. What the voltage regulator will do is take the 10 volt input and supply 5 volts out at 100 milliamps, but the 100 milliamps still has to flow through the circuit. So from the input side, you are getting 10 volts at 100 milliamps, and what you're taking out is 5 volts at 100 milliamps. Now, I'm going to assume 100% efficiency here. Once again, there are all sorts of complications, but assume 100% efficiency. This is the simplest possible scenario. We have 10 volts, 100 milliamps in, so 1 watt essentially, and then we're taking out 5 volts, 100 milliamps, so half a watt. There is a difference of half a watt there. Where does it go? The voltage regulator has to get rid of that excess power, so it converts it to heat and it just emits it. So if you're running a load on a linear voltage regulator, it's going to be pumping half a watt of power out and just blasting it out into the environment. And that is why electrical devices get hot. It's why if you have something like an Arduino, like a classic Arduino with the linear regulator on it, it's got the DC barrel jack on it, and you can plug in power. They usually run at either 5 volts or 3.3 volts internally, but you can put 10 volts or 12 volts or 16 volts into them. The higher the voltage that you feed in, the hotter it gets, because the headroom, the amount of power that it has, the voltage that it has to drop, and therefore the amount of power goes up. So if you have a circuit running at 5 volts, you feed it 7 volts into a linear regulator, the linear regulator is only having to drop 2 volts. It's not going to be wasting much power. But if you feed 18 volts into it, it's got to drop a whole lot more power, so it gets a whole lot hotter. So the temperature coming off the linear regulator is proportional to the difference between the input and the output voltages. Alright, so linear regulators are simple to manufacture and they give very clean output. By clean, I mean the voltage that comes out of them will generally be very stable. It won't have high frequency artifacts in it. It won't have it won't be jumping up and down. It'll just be like a fairly flat voltage. So a linear regulator is very simple to design into a circuit. Typically you'll put like a bulk smoothing capacitor or decoupling capacitor or something maybe on the input and the output side, and the regulator, and that's it, you're done. You've got your voltage output, but it'll get hot. With switch mode regulators, they are much more complicated, and that's part of the reason that I'm giving all of this background. It's a very long-winded answer to what's conceptually a fairly simple question. And it's part of illustrating why this question is not so easy to answer. So to summarize it, the question really is, what are the go-to switch mode regulators for 3.3 volt projects or 5 volt projects? And the reason that I don't really have a specific go-to is these complications. Now, if you want to ignore everything that I'm about to say following this and you just want a simple answer, the simplest solution is to get something like a K-series switching regulator, but they won't do the sort of current that John is asking about. They'll only do like 500 milliamps or 600 milliamps. So the classic linear regulators are things like the L7805. The 7.8 series are positive regulators, the 7.9 series are negative regulators, and the 0.5 means it's 5 volts output. So there's like a 7812 is a 12 volt output, there's a 7805 is 5 volt output. And so there is a series of voltage regulators which just have a K as the prefix, and there is a K7805, there's a K7803, and they are switch mode regulators that are pin compatible drop-in replacements for traditional linear regulators. They're a little bit bigger because they have to have an inductor and various other things inside them, but if you have a design that uses, say, an L7805, you can put a K7805 in it and it will work. And it will be more efficient because it's not dropping the extra power as heat. It's using that switching trick where it's turning on the power turning it on and off very quickly in order to reduce the power that it draws from the power source. So for small projects, I've used the K7805 and the 7803 in a few different projects, and I've used them basically because it's easy. You just put 3 pads down on your PCB and you stick the regulator in place and away you go. In fact, I'll see if I've got one to show you. I probably do. I've got a whole section. Oh yeah, here we go. I'll look for a so here's a comparison. What is this one? Oh, that's an LM series, but it's the same sort of package. So that sort of package is typically what you would see for, say, an L7805 voltage regulator, and then this little tube of things that I've got here. These are K7805s, so that's a K7805 voltage regulator. You can see that it's got 3 pins. This one's got 3 pins, and the pins are compatible. The format is just in, reference, output. So you put, say, like 12 volts in on this side, you have ground in the middle, and you get 5 volts out. Same with this. So wherever on a circuit that you put down an L series regulator, you can put down a K series regulator, and it'll just do the same job. Now mechanically they're a little bit different. It's a bit thicker. As I said before, it's got an inductor and other stuff inside it. It's not as long. It doesn't need the heatsink because it doesn't run as hot. but electrically it's mostly a drop-in replacement. So the very simple answer to that question is, for projects where I just want to run something like an ESP8266 and all I care about is a simple little circuit, I drop one of these into it and I call it job done, and I don't care, like I move on with my life. It's probably not the most efficient, and it definitely doesn't give you the best current capacity, but for most situations I would have to say this is my go-to solution to simple switch mode problems. Now, if you are designing the circuit and you want to optimize it a bit more, you want to go to a bit more trouble and put your own switch mode regulator on there, then the EUP3476 is one that I've used on quite a few projects in the past. That's the one that that John has been using. In my head I'm going over how much do I want to go into this. I'm not sure that I really want to. This is a big topic. Alright, so a couple of things to consider. If you use a switch mode regulator, one of the reasons that it is hard to have a one-size-fits-all solution is the way the switch mode regulator works with the inductor and the way the switching frequency works. Now, switch mode regulators will tend to be most efficient at certain load ranges. If you have a switch mode regulator that is designed for running a very big load and you only take a small amount of power out of it, it will not be very efficient. So you start to lose some of the benefits of the regulator. And there is also a trade-off with switching frequency. Now, more modern switch mode regulators tend to run at much higher frequencies than older ones. And part of the reason for that is that you can use a smaller inductor. Now, once again, I'm going to butcher this explanation. But imagine that, all right, maybe this explanation will work. All right, imagine that you have a dog that is drinking from a bowl, and the dog is your circuit, it's your load, whatever is taking the power. The bowl is the inductor that is in your power supply. And while there is power available in it, or while there is water in the dog bowl, the dog will keep drinking and it will be fine. But if the bowl gets empty, then then the dog will stop drinking. And your goal is to keep the dog drinking constantly. You want to keep it so that there is always water available in its bowl. Now, if that bowl is huge, like the size of a like a wading pool, there can be a lot of water in it, and you can go a very long time between topping it up. The water will always be available, and then you might come back every few hours, and so I'm assuming this dog can drink forever. So you might come back every few hours and put another 100 litres of water into the pool, and you'll top it back up again, and then you can ignore that pool for a while and the dog will keep drinking. But if your dog is drinking from a cup, it might be empty within a few seconds, and so you need to be there every few seconds just putting more and more and more in it, keeping on topping it up. This horrible analogy is a way of explaining the trade-off with frequency and inductor size in switch mode power supplies. So with a big inductor, it can it can store more energy, and it gets topped up in bigger chunks less frequently. With a small inductor, you need to top it up with little amounts of power very, very frequently at a very high frequency. So modern or more recent switch mode power supplies tend towards higher frequency and smaller inductors. So they might be running in the many megahertz region. So they are chopping millions of times per second and topping up tiny amounts of power into the inductor so that there is always power there available for your circuit to use. Low frequency switch mode power supplies use bigger inductors, and they might run in the kilohertz region. So, 1,000 times or a few thousand times per second, it will be putting power into that inductor. It'll need to put more power into it each time because it doesn't do it as frequently. So, but then once you get up into the higher frequencies, you get side effects. You get interesting harmonics, and the design of the traces, the design of the circuit becomes much more critical. So designing a high frequency switch mode power supply is more difficult than designing a low frequency switch mode power supply. But with a low frequency supply, you can use bigger inductors and the whole circuit becomes larger. Hopefully I didn't mangle that too much, and I think I got my point across. Alright, so then it comes down to how much power are you going to pull from the circuit. And this is where it comes down to, if you're designing a power supply for a circuit that is going to be taking many hundreds of milliamps constantly. Actually, this came up very interestingly recently. There was a discussion on the Discord about design of power over Ethernet regulators and the Silvertel modules. So the Silvertel modules that are used on things like the Ether Mega and the Ether 10 on the PoE regulator add-on subboard are designed to take in nominal 48 volts, and then they give you an output. There are different versions, so they can output 12 volts or 10 volts or 5 volts or whatever, and use that for your circuit. So what happens is that the power over Ethernet system supplies 48 volts down the wire, and the regulator then converts that to, let's just say, 5 volts on the output. Now, if you on your on the load side are pulling a couple of hundred milliamps, what you're doing is keeping power flowing through the inductor, and the circuit, the voltage regulator circuit in that PoE regulator is sized optimally for loads that are pulling a few hundred milliamps, like somewhere in that region. The problem comes where you have a circuit that is very low power and it's not pulling much out of the regulator. The regulator can start to have trouble, and this is where the inductor on the output of the regulator is not having the power pulled out of it, and the regulator is trying to, let's just say, slow itself down so that it's not putting power into it very frequently. But it might be running at a fairly high frequency, so it's checking more power, more power, more power, more power. And the power is not being drawn out of the inductor fast enough for it to for there to be space or capacity for more power. And this is where switch mode regulators can start to fall over. They don't really like running with loads that are at a very, very low power that is outside of the range that they were designed for. So switch mode supplies are normally designed to work within a specific range. Like they'll say, it outputs 5 volts and it's most efficient between 200 and 500 milliamps output. If you use that same regulator and you try to pull 50 milliamps out of it, it'll probably work, but weird things happen. One of the things that just came up on the Discord during the week discussing this was they can start making audible noise. And that's because the inductor is being mechanically stressed by the by the electromagnetic field and by the switching frequency that is being used to drive it. And I'm not an expert on this, so I'm not going to go into this in more detail, because once again I would be sending you off down the garden path and giving you incorrect information. I only have a very shallow understanding of this area, just based on what I've seen working with different switch mode power supply designs and the different ranges at which they work. So what it comes down to is there is no one optimal switch mode power supply for hobby projects that will work efficiently across a very wide range of applications. They have different attributes and different efficiencies at different loads. So for the for do-it-yourself PoE, I do quite like the EUP 3476. It's fairly efficient. You can be putting 24 volts into it, pulling 5 volts out at 100 or a couple of hundred milliamps, and it's perfectly fine. You can pull 2 amps out of it, and it's perfectly fine. But for other applications, that may not be the best one. I think I'm running out of things to say about that. Things to say that have any basis in truth anyway. Alright, so let's see what other questions we've got here. Alright, so looks like there have been some comments. Ray Ralston, Dodgy Brothers and Scott Miller have been discussing labeling issues for electrical installations and non-standard wiring. Yeah, I'm a big fan of labeling. I'm amazed by how few electricians label things, or label them in very weird ways. Like they'll put a letter or a number on something that means absolutely nothing. I'm really a big fan of over-labeling, if anything. And I think there was a comment in the chat earlier about using non-standard wiring, or using wiring for a purpose that it's not designed for, and having an inspector not sign off on it. But I'm not sure where that I'm not sure where that comment was. Okay, so Andrew Gordon mentioned using a switching regulator to get close, then linear regulator for the final output seems popular. Yes, it is. I was actually going to mention that, and I totally forgot about it. I have done that myself many, many times. Let me see if I can find an example. I'm just pulling up Eagle now, and I think I might have done that on... Did I do it on the chair breakout? No. I think I might have done it on one of the versions of the ESP remote project. Let's see, does that have a linear regulator? This one used to in an old version. ESP relays, does that do it? Yes, okay, so here is an example. I'm going to pull this up, hopefully Eagle will behave, and I'm going to switch over to desktop sharing in just a second. Where is my desktop? Right there. Okay, so what, oops, wrong program, schematic. Let's have a look at the power supply for this. Down in this section right here. So this is, sorry, who was it that suggested this? Was it Scott? Oh, Andrew Gordon. Yeah, okay. So Andrew, thanks for bringing this up. This is a really good point. So what we've got here on the left is input from the power source. So in this case, I've said that it's rated 5 to 24 volts DC. Now, I probably should have actually said something like 7 to 24 volts DC, because voltage regulators need a certain amount of overhead in order to be able to work. In order to run itself, it needs a small amount of power. Once again, I'm not going to get into this, but basically if you have a voltage regulator that you want to have 5 volts output, you generally can't feed 5 volts into it. You need to feed like 6 or 7 volts into it because it's always going to drop a small amount. Now in the data sheet for the voltage regulator, it'll say what this is. There will be a spec which is the minimum threshold on the input to achieve the desired output voltage. So in this particular case, you can see here the K7805 regulator, and we've got the input coming in here on the left, there's a ground reference, and there is the output on the right. Now if we truly wanted 5 volts output here, we could not feed 5 volts into it. We'd need to feed 6 or 7 volts into it. But I screwed up there. I should have said 7 to 24 volts DC input to be safe. So what we're doing in this case is taking the output of this switch mode regulator, feeding it to a decoupling cap. So we've got a 10 microfarad cap here, and this gives us a 5 volt rail. Now in this particular project, the 5 volt rail is used elsewhere. If we come down here and look at this part, this is a relay. So that's a 5 volt read relay, and you can see that the supply to the relay is coming off that 5 volt rail. But let's ignore that for now and go back to the power supply, and you can see that that 5 volt rail is also going to the input of an AP212K 2112K linear voltage regulator. So what we have here is a switching regulator taking the normal input power, which could be up to 24 volts, giving you 5 volts, and then that goes into a linear regulator which takes that 5 volts and gives 3.3 volts output. So you might be asking why you would do this. There are a few reasons. In this specific case, it is because we need both 5 volts and 3.3 volts in order to run the relays of 5 volts, and the ESP HS66 is running off 3.3. So it makes sense to use these two regulators. Now this could have been 2 linear regulators, it could have been 2 switch mode regulators, but this specific combination really plays to the strengths of both types of regulators. So what we've got is the bulk of the power drop happening between the input, which could be 24 volts, and the output of the switch mode regulator, which is 5 volts. So we could be dropping 19 volts of power across this K7805 regulator. And that's really what switch mode regulators are best at. It's very efficiently doing a conversion from a fairly high voltage, well, high in this sense, 24 volts, down to a low voltage of 5 volts. And if we were using a linear regulator for that, we would be burning a huge amount of power as heat, so the whole circuit would get quite hot, because that extra 19 volts at whatever the current rating is, the current is that's being drawn, would have to be emitted as heat. So what we get is the cool voltage dropping effect of the switch mode regulator coming into the input of the linear regulator. So the linear regulator is going from 5 volts to 3.3 volts. So it's not having to drop a whole lot of power. It's only 1.7 volts at whatever current we're drawing that we are going to be emitting as heat coming out of this linear regulator. Now, you might ask why a linear regulator is preferable in some situations. Now, earlier I was talking about the switch mode regulator internally turning the power on and off very quickly at either kilohertz or megahertz frequencies in order to generate the output. The result of that is that the voltage that comes out of a switch mode regulator is not necessarily a dead flat line. If you look at it using an oscilloscope, you'll see that there is typically a little bit of fluctuation on it. There will be very high frequency components superimposed on that power line by the switching frequency. So that can, unless you decouple it properly, that can cause problems in the circuit. Now, for a well-designed switch mode regulator with good decoupling, that's not going to be a problem. But sometimes you will have issues like microcontrollers that will reset or do weird things if the supply voltage is not smooth enough. So in this case, what we have is the output from the linear regulator giving us the 3.3 volt rail, and this will be really smooth, because what's happening is that the power is coming from here on the switch mode side, going through the linear regulator, which is just giving us a constant 3.3 volts output. And essentially what it's doing is isolating the 3.3 volt part of the circuit, including the microcontroller, from any of the switching artifacts that will be coming from the switch mode regulator. So that is an interesting little trick, and thank you, Andrew, for bringing that up. It might be something you want to keep in mind in future if you're designing a circuit. So do the bulk of the drop using a switch mode regulator, feed that into a linear regulator, and then use that to run the noise sensitive parts of your circuit. Best of both worlds. And just to see what it looks like, let's just turn off some layers here, because it's get rid of those layers. And what we're looking at down here is the power jack. So this is the power jack coming in from the bottom. Over here we have the K7805, so that is the footprint for that switch mode regulator. That's giving, so it comes in on this side, that's power in, gives us 5 volts out, and then that 5 volts is coming into the 2112 voltage regulator, which is the linear regulator, which gives us the 3.3 volts out, that then runs the rest of that circuit. So then we have both 5 and 3.3 volt rails available. Pretty cool. Okay. I'm going to switch back to schematic and just leave that there for a second while I look at other questions. So what else do we have? Yes. What have I missed? And how am I doing for time? 11:48. Wow. Almost 2 hours already. I think this has already been addressed in the chat, but Alex Garner asked, would I recommend 6, Cat 6, 6A or 7 for a new house build, probably related to labeling and cabling discussion going on, mentioned above. Okay, so I don't really know what to recommend there. This is we're in an interesting time, I think, for transition of cabling standards, and I think there might have been some comments in the chat about this. Let's switch back to internal camera and get rid of Eagle, and okay, there are probably experts on this stuff that that have better opinions than me on this. So there are a couple of different applications here. Now for things like my light switches, okay, so I'll tell you what I've currently got, which is not necessarily the ideal, but it's a couple of years old. For my light switches, which originally I was using 100 megabit Ethernet for, so I had I had Ether 10s and I had Ethernet inside every one of my light switches. They were all running off PoE. At the time the cable for that was installed, it was done using Cat5e, and that was, how long ago? Must be 10 years ago, somewhere in that region. Anyway, whenever it was done, Cat5e was like the standard high-speed cabling, and it's now been very well superseded by several other versions. But if you're doing 100 megabit or even gigabit, Cat5e cabling will do the job. Now for light switches, if I was installing light switches today, like if I was doing the whole job again today, I would still run Cat5e to my light switch locations. And that is partly just because it's so much easier to deal with. Once you go to Cat6 and above, the requirements on the connectors become much more stringent. The cable is thicker. It's harder to crimp the connections. It's just it's harder to bend. It's harder to drag. The cable costs more, and essentially it's overkill for something like a light switch installation. The hookup. Hey, nice to see you here. So what about when your light switches need 100 gig duplex? Yeah, for that, for getting that message through right now. And Dodgy Brothers said run conduit down the wall, so if you need to do a rewire, you can do it quick and simple. Yeah, so conduit is the simple answer. Make sure that you can recable in future if you need to, because maybe we'll need optic fiber going to our light switches. So my current system, I have Cat5e going to my light switches, and I have Cat6 going to all the data points in my house. So the data points were wired when the major renovation was done, which was, must be about 6 years ago, give or take. And with that, I can run gigabit easily, like that's not a problem. And I could run 10 gigabit across that if I needed to. I don't think I even have any computers capable of 10 gigabit at the moment, but it could be done. So in terms of what wiring I would use now, I think I would still use Cat5e to my light switches and maybe Cat6 in conduit to my data points. Maybe 6A or 7 would be worth doing, but I don't know. I haven't looked at that recently enough to really know what's involved. It's a little while since I've worked in a data center or done any of that sort of hardcore cabling work, so my knowledge is years out of date, and in this industry, years is a lifetime. You might as well not even, yeah. My knowledge is like wet string and 2 cans. Alright, so Ayush Varshney asked, how can I automate my automobiles? So that is a very general question. That is also a really interesting one. Given the time, I'm not going to get into that right now. I've done a lot of car hacking in the past. I used to run a site called geekmyride.org, which was all about hacking car electrical systems and retrofitting control. It's something that I've wanted to do in the past, more of on the SuperHouse channel. And in fact, let's see if I can find a controlled by iPod Touch. I'm going to see if I can find a video that I'm going to drop in the link. Right, this is a video that kind of got me a whole lot of exposure early on with my YouTube channel. And I'm going to find another one that was filmed by another friend of mine a little bit later. Similar topic. Drop this one in as well. So these are both related to some stuff I did on my RX-8 about 11-12 years ago, where I modified it so that it was connected to the internet. And I've talked about this on live streams in the past. I'm not going to go into it in great detail now, but this is an area that I think has a lot of opportunity. I think the idea of thinking of your home automation system not just as being your house, but thinking beyond your house and seeing your car as being an extension of it is really interesting. Things like, there are obvious things like geofencing that you can do so that your home automation system knows when your car is approaching the house, and it can turn on lights and all of those sorts of things. But that's a really big topic that I'm not going to get into right now. And there is a section in the Discord to talk specifically about this. So if you want to follow that up, maybe check out Discord. There is a section for car hacking. And it looks like James has already followed up some questions. So just as a very final wrap up, might even finish almost on time today. I'm going to have a quick look in the chat and see if there's anything I should be... Oh, okay, so Scott said, my home automation system encompasses 3 houses and a farm in 4 towns. Yeah. So once again, this is a very interesting area. Once you start getting beyond just a single house and you start thinking about bigger picture things like smart cities and integration between houses, if you personally have multiple premises that you need to look after, then some level of integration between them can be useful. Many years ago, Andy and I did a bit of an experiment where we created an MQTT bridge so that we could link some topics between our houses together. Now, it was a bit of a half-hearted attempt. We got it working, and we never really pursued it. I don't even know where that code is anymore. It was kind of an experiment just to see what would happen. So what we did was created a bridge that would allow 2 different MQTT brokers to be linked together so that topics from one could be reflected in topics on the other. And then what you could do is have information exposed on someone else's home automation system. Now, one application for this could be, I think part of the reason that we never really pursued it was that it was like a solution searching for a problem. It was something interesting to experiment with, and perhaps Andy can talk about this in the future. And you could do things like, I could, in my house, have access to the information of what the temperature is in Andy's house. Now, what's the purpose of that? I don't know. Maybe things like sharing meteorological data across an area could be useful. Yeah, as I said, it's kind of a solution searching for a problem. But if you personally have multiple houses, like maybe you have rental properties, but that's probably not a great example. Say you have some properties that you're using for Airbnb, and you have short-term guests, people that are coming to visit. They're staying for a couple of days and then leaving. you might want to do things like be able to control the access control system remotely, so that you can you can issue a one-use code or a short-term code to the guests. You want to be able to update the access control system so that they can arrive, type the code into the keypad at the door, and they can get inside. And then later, once their tenancy has finished, a few days later they've left, and you've got a new guest coming along, you might want to be able to update the security and give a new code to the new people and lock out the people that have left. So there might be situations like that where you want to be able to integrate across multiple premises. Anyway, this is all just my brain ticking over general ideas and looking for a problem that this can solve. So, yeah. Oh, and well, Scott said it's nice to be able to have the Google Home in my office yell at me if the pump house tank at the farm overflows. Yeah, those are, yeah, that sort of thing is a really good application for it. That's a good example. I'm going to wrap it up. Thank you very much for everyone coming along today. It really feels like today I have been making stuff up as I go and talking about subjects that I'm totally unqualified to talk about. And hopefully I didn't mess you up too much and send you down the garden path. And I hope you all have a fantastic weekend. And if you are a Patreon supporter or a GitHub sponsor supporter, jump into that restricted section on Discord, queue up some questions in there, and I can get to them next week. Now, of course, that doesn't mean I won't answer questions from the general chat. Anyone is welcome to ask questions, and I'll try to answer them. It's just that if people can get me questions beforehand, it means I have a chance to think about them and maybe have a coherent answer instead of just rambling like I have today. So, thank you very much. Have a fantastic weekend, and I will talk to you all soon. See ya.